people, don't cough on each other. Blow your nose into a tissue.
I can't remember who it was, but he sneezed all over me.
All right, here we go.
This topic is all about angles. We will look at what you should know about the measures of two angles that form a right angle, and what you should know about the measures of two angles that form a straight angle. Two intersecting lines form angles, but how can you describe the relationship between the angles that are opposite each other? Finally, in this topic, we will see that you can use relationships between angles to break complex diagrams into smaller parts, and just as importantly, how to decide which relationships to use. Well, I'm glad we got all that straight, because it's time to get going now. See you round.
I wonder if your answer will be right. that's no, it gets right. Well, no, I'll save the other one. Yeah. You will once we dive into this further. So, let's look. Actually, is the launch on your paper?
An angle is a figure formed by two rays with a common endpoint. You can name the angle shown, angle A.
Anytime we have angles, really they're made up of two lines or two rays. What's the difference between a line and a ray? Like when we draw it, what's the difference, Isaiah? A ray has a beginning point and a line that continues on forever, whereas a segment has a beginning and an end point. So we have rays here because they go on forever, but BA is a segment in that ray. Since there's a start and an end point, BA is a segment in that ray. Now we want to talk about angle notation. We do have a launch on here. Sorry, I got a little bit ahead of myself. So if we look at the launch, it doesn't say launch on your paper, but it's the first thing we have. If we looked
That's
at
pretty cool.
Yeah, I just invented it. It's called a flangle.
Flangle?
Yeah, a flying angle.
Those are paper airplanes, dude.
How could I
No, they're flangles. Flangle is a more accurate description, and it sounds better.
I'm leaving now.
Or a protractor. Sorry, compass is normally a standard first answer, but I don't know what you guys worked with compasses. That's scouts.
You could use your thumbs like this.
Oh, so wait. So Thomas is saying you could use your thumbs like this. Now you really can't use something else as a reference point. So if you took another piece of paper and laid it over top and traced that angle, or I, because I have the smart board, can just trace this angle, and then I can grab it and drag it and compare it. Now I would need to turn this, which I can't in this program. If I'm actually in the smart board, I can turn it. But you could use something else to compare the size of the angle. Now fortunately, we are further along than Pythagoras and all those old guys who invented geometry, and we have a protractor. So the easy way to compare these angles is to use a protractor, but we have to make sure that we know how to use it correctly. So when we use a protractor, what's the most, actually there's two really important parts about using a protractor.
An angle.
Make sure it's straight.
What do you mean straight?
Like even, make sure it's, I don't know.
So what's the first thing we do when we're going to try to measure an angle with a protractor? First thing, and you can see it in your picture, we're going to notate it in your notes. The first thing we care about.
You could put the little center, the line that meets in the middle of the protractor. Line it up.
So your vertex of the angle, the vertex is where your rays meet. You can put vertex in the T or crosshairs. If you guys play first-person shooter games, you know what crosshairs are. These are crosshairs, like a target. You are putting your vertex in this target in the dead center. So you want your vertex. That's the first thing you do. But putting my vertex in the dead center is only so good because still my protractor could turn with my vertex in that center. It could do whatever it wants. So the other thing we have to do
is line up the bottom line with the bottom of the protractor. So on these, there's a tiny line on the bottom just under the center bit.
Yeah, it actually goes over from the crosshairs. Yeah. So you can follow it from the crosshair straight across. Now, it actually doesn't matter which ray we use. Here, they use the ray BC and they line that up with the 0 point. But if we turn the protractor, we could use BA as long as we lined it up at the 0 point. So then I pose the question somewhere. Oh yeah, it's down in the got it. How do we know what set of numbers to use? Like, we need to fill in what ABC measures, what the angle measure is. It's blank on your paper for a reason. How do we determine what number set to use?
Angles opening to the right, you use the bottom scale, and angles opening to the left, you use the upper scale.
You're right, but that's kind of a little complicated way to explain it. Because depending on the protractor, the numbers might actually be top, bottom, right. Like, they might actually change places. Whatever number set my ray goes through 0, that's the number set I'm looking at. So up here on the screen, these numbers that you see in blue, those are the numbers that we care about. Ignore the numbers in black. Because when I come up here and I look at, well, what is the angle measure right here? Because that's where my ray goes. I have two options. I see a 135. That is not what I want to use. What I want to use is the bottom set of numbers, which is 45. So we always use the set of numbers that my 0 is on. Notice the 0 over here doesn't matter. That has nothing to do with my angle. Questions on that? That's where people make their mistakes. Also, once you work with angles and know that 90 degrees is a right angle, it's easy to see this has to be less than 90. It's smaller than a right angle. It's a cute angle.
Oh my gosh, that's so funny.
Sorry, that's my last. My divine button. So hey, make sure you fill this in. ABC measures 45. Make sure you fill that in. And degrees. It's not an angle if it doesn't have degrees. Now this, huh?
Should we bring our own protractor tomorrow?
If you have it, sure. Yeah, if you want to use your own. Now the other, and I doubt you've probably seen this floating around the internet, but people sometimes when they understand math will use it to make jokes. So you've maybe seen with signs out in front of restaurants when there's like a blizzard or really cold weather. Do you know what I'm going to say? No. So it's I'll get your question in a second. It's like a joke advertisement where they say come inside and sit in the corner. It's always 90 degrees. Because the corner is always 90. There's pictures online of like restaurants that put that on their signs out front. All right, so sorry, your question.
What's on the top number? Is this like above the thing?
90?
No, right here. Above the actual.
Make sure, by the way, make sure that you can read the text at the bottom. If you cannot read the text at the bottom, you are looking at it incorrectly.
Yeah, so it's just.
What do you mean? What's on top of?
Right here.
Oh, those are the other angle measures. Are you talking about the opening? The opening is just to see your line, see where your line goes through. Because then there's other protractors. So guys, there's multiple types of protractors, and you can check out like all the ones that I have. Some are just completely open through the middle, but then they have a little piece that you can't move with your angle. Some are clear, so you can see through them.
That's what mine is.
So I'll just leave some examples up here. So when I look at angle 1 and angle 2 here with my skier, anyone go to ski club last night? Was it good?
Yeah, it was nice. It was warm.
Yeah, it was a warm night to go ski. So angle 1 is the angle between his skis. It's hard to see on your paper, but it starts back here. Well, that's still hard to see. Change into green. Starts back here, follows his one ski up, and follows his other ski. So when we drag my protractor over, the first thing we do when we set our protractor down, the vertex in the crosshairs. So drag your protractor over and get your vertex in the crosshairs. And by drag, you're just placing. But notice I can still rotate. I can still rotate. So what do I have to do next? I first place my vertex, or really I place my crosshairs, my T at the bottom on the vertex. It's hard to see on your paper, that's right where the skis meet. Now I want your eyes up here for a second.
The skis are
Angle 1 is the angle between the skis. Vertex is back here where the skis meet. I know it's hard to see on your paper. Okay, so we're doing angle 1 first. On your paper, your vertex should be right here. Where like that little white part goes up in, that's where your vertex is. So you probably want to draw that again. Then it follows his, notice how in color it's easier to see. This printed black and white, so it's harder to see. But I have a question for you. Can I, once I place my vertex here, I need to set my 0, right? So can I set my 0 like that? Yeah, for the second angle I could, but not my first angle.
Whoa.
And actually my second angle is way bigger than what you're looking at. So for my first angle, I either need to set my 0 on my bottom line, or the other way that I could place my 0 is if I do this and put my protractor pointing down. We still get the same answer, we just read from a different set of numbers. Now it's easier to look at it like this. And what do we get? We get approximately
10 degrees.
Yeah, about 10 degrees. So we draw the angle symbols. Now, I put a little, a curve or whatever in. A lot of times in digits, you're just going to see it like this. Anyone figure out why I add this to my symbol? Cassie? So it doesn't look like the inequality. The less than symbol and the angle symbol are almost identical. The less than is supposed to not be straight, and the angle is supposed to be flat on the bottom. Notice how these are flat on the bottom. I would prefer if you get used to just making your angle symbol with a little loop in the corner. Because what you're really saying is the size of this angle in here. But over time, as we've like just done it quicker and quicker, we just draw the angle symbol and draw a little loop. So we say angle 1 equals about 10 degrees. Gotta have the degrees symbol. Now angle 2 is actually an obtuse angle, guys.
What?
Angle 2 starts at his foot
Oh my gosh.
and follows the ski back
Where's his foot at?
and follows his body up. So I'm gonna highlight it. Well, if Smart Ink comes up.
I'm still confused. Where did you
It's easier once we move on from the skier. I don't know where my Smart Ink went. Here's angle 2, a different look because I'm back in your notes. This is the first part of the angle following his ski. This is the other part of the angle following his body up. So we're looking at the angle that he makes from his ski to his body, because when long jump skiers make the jump, they lean as far forward as possible so that they're cutting through the air, so they have less wind resistance. So I drag my vertex. Oriana? Cool. I rotate to set my 0. What'd you get, Oriana? You're close. I think it's actually supposed to be 155. If I look right here, notice, here's my 0. I'm going to use the bottom set of numbers. So I go up my numbers till I hit my other ray. That's right in there, which looks to be angle 2, equaling about 155. If you had 160, that's okay, because you're close. Okay. Yeah, it's just how it printed. You're going to get a little bit of error. which is okay. Like, that's fine. If you have 160, that's fine. I do. So figure out what's the measure of this angle. The protractor's already on your paper. What is the measure of this angle? And notate it correctly. There you go, sir. Katie, do I hear you use the bottom or like the inner set of numbers or the outer set of numbers? What was that? Sorry. The bottom, like the inside set? Yeah, because when you look at your ray, and I'd like you on your notes, draw a little arrow to the fact that that's where your 0 is. You're looking for your 0. You follow that set of numbers. Looking for your 0, follow that set of numbers. So you follow it up to my other ray. It crosses right here. Angle CAB equals about 105 degrees. Now, hold up. Why is it angle CAB? Could I have like CBA or ABC or like... Well, Luke, so I'm trying to vary people.
Oh, because Cass spells out a word. Well, it's because, well,
Hey,
one,
chill.
this is sometimes how I read them, is C is sort of to the left of A, but it's also because it's like there. It goes from one side to the other.
You have to go in order from an endpoint to the vertex to the endpoint. Really what matters is that your middle point is the vertex. Because I could also call this angle BAC, working from right to left, and that'll still be 105 degrees as long as your vertex point is the middle of what you name your angle. Okay.
So, what you do is when you go up there, you like make it where it's. Can I go up there?
Yeah.
Yeah. Okay. So you like make it where this part is to the other 0, and so it's just in order.
Oh, so if you turned your protractor kind of. Now on your notes it asks you how do you decide which set of numbers to use. I would like you to write look for the 0, or however will help you remember that. Look for the ray crossing the 0. And I say ray, but it can be a segment, that's fine. Most angles that we look at, though, are composed of rays. We name it using segments, but it's composed of rays. So now here, we want to draw out the different types of angles that we're asked. So our first set, we want to draw a straight angle. Now some people like straight angle, that's like an oxymoron. You moron. No, but straight angle is an angle that's actually straight. When you hit an intersection, when you're driving and you hit an intersection, yeah, when you're driving, of course, you have normally 3 options. You can turn right, normally at 90 degrees. You can turn left, normally at 90 degrees. Or you can go straight. You cannot decide to do nothing, or else you'll sit in the intersection and be arrested. So if you think about a straight angle, if I'm coming down this ray and I hit this intersection, how do I make a straight angle?
You go straight.
Just keep going. So, but what you want to do is put arrows on both ends, draw a vertex in the middle, so draw a dot big enough, and then I need you to draw a little arc and label it as 180 degrees. All straight angles measure 180 degrees.
Really?
So really, if you need a visual for it, if I start looking straight forward, I can go 180 degrees to the right, and be pointing straight backwards, or I can go 180 degrees to the left and end up pointing straight backwards. Doesn't matter what direction. So you can go 180 that way or 180 this way. They're both going to be equal. Now when we look for an obtuse angle, I'm going to draw you two options. You only need to draw one option on your paper. You can draw two if you have colors, but if you don't have colors, I do not suggest it. If I start out here, I hit my intersection, should I take line A, B, or C to make an obtuse angle? C, because it has to be bigger than 90 degrees. So if I were to approximate what this looks like, I'd say this is probably about like 120. I mean, you can put your protractor on top of it and measure and find out.
125.
What you 125?
Yep, it is 125.
Yeah. Well, I'll correct it then. Now, what though? Changing colors. If I start here and go this direction, I would want to follow A. But now this is the 125 degrees. So we can draw two different obtuse angles there, depending on what ray we start on. Now, right angles, always so right. I'm often punny, so I don't know what makes today especially punny. How many right angles can I draw here? Well, okay, I for sure can draw one. I need to be careful how I phrase it. So if I start on this ray, come right here, how do I notate that something's a right angle? I don't need to actually write 90 degrees. I could do this and say 90 degrees, or, Layla, I haven't talked to you today. We complete the drawing of a square in the corner, because squares require a 90-degree corner. So when I draw, so I make a square in the corner to show that has to be 90. Now I can also, if I start on my other ray and come this direction, go straight up the same line, and I can get another 90-degree angle on the other side, and two 90s will always make a straight.
They're always so straight.
Two rights make a straight. Which actually, when you're driving, that's not true.
Yeah,
Two rights make a U-turn. Yeah, if you're going straight, you turn right and you turn right, you're pointed back to the direction. But think about it. If I'm going this way and I turn a 90-degree angle and then I turn a 90-degree angle, I'm going back the direction I came, which was a 180-degree rotation. So it's kind of like, so instead of continuing straight, I flip it around and going back the other direction.
How come you can't just throw it on reverse instead?
You normally don't drive in reverse.
I know.
And a cute little angle. Draw some cute angles on your paper. We can draw one here. Somebody measure this and let me know what you get.
Oh, okay.
35?
It's about 55.
Yeah, I was about to say it's going to be bigger than that. So if we have 55 here, then I can use the complementary angles theorem. Now, here's what I'm going to start teaching. This is a little bit ahead, but here's a saying that I want you to get used to. To compliment someone is the right thing to do. So, complementary angles add up to be a 90. So this red angle and this blue angle are now complementary because together they make a whole right angle. So what does my blue angle have to measure to add up to be 90?
It have to be
35 degrees. We could also label another angle over here as an acute angle. Say that's 55. And you can kind of just remember these if you have an issue. I don't know if you guys have any nieces or nephews or anything like that, but normally when people talk about things being cute, they're small. So babies are cute. When people talk about something being obtuse, and actually that word can be used in language for like, why are you being so obtuse? Which does not mean why are you being more than 90 degrees. So I would challenge you to find out how it is used in language. If somebody says like, why are you so obtuse?
Grumpy.
No.
Does it mean like
Oriana? Huh?
Like, is there another 90 degrees?
ow?
There's another acute angle. I just ran out of colors.
What about black?
Well, yeah, I mean, black is like the absence of color. Here would be another acute angle.
Yeah, but wouldn't there be another one like that? Like a
So, that is what we would have to figure out. If I switched.
No, the V is the.
So, hold up. What Oriana's asking about, actually, I'll still highlight that, is this angle here acute? Now, for us to figure that out, if this was 35 and this is 35, what would it measure together?
It's about.
From here to here.
It's about 78.
Is that what it measures or what you added up? Because if I add these up, it should be 70.
It looks like a right angle. I got it looks about.
So, do not trust how things look. Trust how you measure them, or if you're told values for how big it is, trust the values that you've been given.
Classify the following.
So, we want to use, I mean, you can write out the whole words if you want, but we can abbreviate R for right, O for obtuse, A for acute. So, I'm just going to use cards here. Bella, my first one. It's a right angle. My second one here, Karina. My second angle, what type is it? Obtuse. My third one here, Brennan. A cute little angle. My next one, Thomas.
Obtuse, yeah.
Yep, obtuse. Bela. So, this one is really, really tough to see. It is acute. This one leans in a tiny bit. If you put a ruler on this and continued on the same line, you'd see that it starts to come in a little bit more. So this one is actually acute. The other thing that should notify you of that, there's no right angle symbol in the corner. So you can't assume it's right if it's not been labeled right.
So you know I always be right if it's a square.
Yeah, if it's got the square in the corner, you know it's a right angle. And my last one here, straight angle.
It's not an angle.
Well, it is.
What?
If there's a vertex in the middle, it is an angle, but it's a straight angle. So it would go from here to here. Questions, comments, concerns? I want you to write out in the got it every angle you see and what size it is. So you've got a protractor to measure. I want you to write out every angle you see and what size it is. So if we write like angle, we would name it with 3 points. You cannot just say angle O. That's where every angle's vertex is. So you have to use the 3-point notation. So the first one I see is like AOB. And you'll use your protractor to figure out how big that is. I will tell you there are 3 angles up here. And actually, there could be 5 if you get real, if you look at greater than obtuse or on the opposite. So what I'm saying, and we don't do this, so don't let this confuse you. We don't do this, but you could say the greater angle, BOA, and you'd be looking at this angle, but we don't do that. Like, we barely ever deal with things like that. Sorry. Layla, did you measure AOB yet? What'd you get? 30? So if you have anything close to 30, you might have a slight error in your protractor. Abby appears to be sick again. Abby, feel better.
I got 150.
Don't die, Abby.
You're measuring. Keep that thought. So in blue was this angle right here. What you just brought up, Karina, is actually angle BOC, or COB if you want to flip it around. And that angle right here measures 150.
Wait, don't take it.
Now, does anybody know when I add those two angles together, what they're called? Their relationship together.
Is a straight.
Complementary angles they make 90. They're pairs that make 90. To complement someone's the right thing to do. What's it when a pair makes 180? Cassidy?
It's a mixed straight.
It does start with an S. I agree, it's going to be a straight angle, but that's not what we call the pair.
It's not a gay.
What is it, Isaiah?
Supplementary.
You're close.
Yeah.
Supplementary.
Yeah.
So when I add AOB and BOC, they add up to 180. That makes them supplementary. But then when I look at the angle, I would label it AOC to start at A, go to O, end at C, and that would be 180 degrees. Because it's a straight angle. You can see that. So if you want to make a little note here, you could say that these are a supplementary pair.
Did you hear about that, Mr. Hudson?
No.
Bella, that's all straight point. That's cheesy.
All right, now let's practice some problem solving with angles. You know angle 1. You know it by looking at it. You should know it. You're told it measures 3x minus 15, and you're asked, what is x? So when I look at angle 1, what does angle 1 actually equal in real life, right? 90 degrees. So what we do is say that 3x minus 15 is equal to my 90 degrees. Because Jovan, you should be writing with your pencil, not tapping. If you guys don't figure out how to control that in class, we're going to stop doing it in forum. So what would I do on both sides always, Oriana? What do I do to start isolating the x? But we see it's minus, or it's a subtraction. So we add 15. That gives me 3x equals 105. What do I do now, Luke? Divide by 3. And that gives me that x is 35. Now, I do not have to put degrees on that because when x plugs in, it's just a number and the degrees symbol is already out here. So x is just a number. It's not an angle. It's just a number inside the angle value. Try the got it on your own. No, it's told to you.
Got it. Oh.
The measure of ABC is 60. Find out what x is. All right, Zach. What do we got to do first here? We got to do what? We have add, because it is subtracting. We want to add. Sorry, I'm not hard of hearing. I just try to make you think about it again. Well, I'm kind of hard of hearing. Drumming for years does not help your eardrums.
Oh my goodness.
What do I do now, Divine, to finish this out? Yeah, we divide by the 2. And x is 45.
Okay.
If you were absent today, I sure do hope that you feel better soon. Email me, text me if you have questions. Try the homework.
Bye, YouTube. Don't get